All right, friends, 12 noon sharp India
Perfect.
time.
So let's get started right on time.
Right on time. And introduce all of you to Ben Weissman, and B for Ben, B for big data. Ben is an expert in when it comes to big data. He has been working with SQL Server since version 6.5, and he specializes in big data, data warehousing, MPP, massively parallel processing systems. And today's session Ben has is on SQL Server 2019, big data clusters, make SQL Server your data hub for everything. Ben is also a friend and MVP colleague for many years. Ben, thank you so much for supporting our community efforts and joining us today. Over to you, Ben.
Thank you for making this happening. So let me start my presentation here. I think Satya, you need to stop yours first. There we go.
Yes, Ben, now you can share. I've stopped mine.
Yeah. Perfect. All right. So thank you very much for joining me. Good morning, good afternoon, good evening, good night, depending on wherever you are. Thank you so much, Amit and team, for making this happening. Also, thank you so much to the knowledge partners for supporting this event. Given these times, I think it's a great thing that we can have these virtual conference and all still keep learning, connecting, and network together as good as we can. So yeah, thank you very much for making that happen. Amit already introduced me, so very brief. Ben Weissman, I'm a data platform MVP from Germany, been working with SQL Server since version 6.5, so quite a while. And one of my specialties is indeed, besides data integration, the topic big data clusters. I was hoping to present that at the Data Platform Summit this year, so let's see what's going to happen there. But now let's start with a brief overview what that product actually is. So, in theory, before we would get started on big data clusters, we would need to look into a couple of technologies: Spark, Kubernetes, Hadoop, Docker, Python, SQL on Linux. While we will obviously not do a deep dive on all of these topics because it would be a little too much for just about an hour, you just have to keep in mind, and you have to be aware, this is what makes big data clusters. These are the foundational technologies of big data clusters. For example, SQL on Linux, big data clusters only runs on Linux. Just let that sink in for a second. If a couple of years back, I would have been here or at an in-person event and have told you that I'm going to install SQL Server on Linux, everybody would have been like, that's not possible. SQL Server only runs on Windows. And then Microsoft gave us SQL on Linux. And now we're at a point where Microsoft is actually giving us a product, SQL Server 2019, big data clusters, which only runs on Linux, which I think is super interesting and exciting. And it runs on a platform called Kubernetes using containers, and it uses Spark and Hadoop and Python. And we're going to take a brief look at what that actually means, what these technologies do. And then you will have to decide, depending on your role, are you a data scientist? Are you a T-SQL developer? Are you a DBA? Are you an architect? What are the topics that you will potentially need some in-depth learning when it comes to details? There's also a couple of great follow-up sessions at this event on some of these topics, so I highly encourage you to attend them all. So a little more specific, what is a SQL Server 2019 big data cluster? First of all, it's just a SQL Server, but it has a little more infrastructure around it. And using that infrastructure, it will solve three main topics, three main issues, three main feature sets, whatever you want to call it. The first thing, and that's also why I called this session, make SQL Server your data hub for everything. The first thing is data virtualization. You may have heard of Polybase, and we're going to take a deeper look at what this actually means. The idea of data virtualization is bring in data into SQL Server without having that data actually sit in SQL Server. So instead of copying everything into one database, the data may reside somewhere else and still be available to be queried in your SQL Server. SQL Server becomes a scale-out solution, so you can spread tables across multiple, not just databases, but across multiple instances. And SQL Server becomes its own data lake, which is especially exciting for those of you that are still on-premise and that maybe can't move to the cloud for technical, for legal, for whichever reasons. Data Lake is coming to you, and it is coming to you as part of SQL Server. So if you deploy your SQL Server Big Data Cluster, it will deploy a data lake for you. And last but not least, it becomes a full platform for machine learning and artificial intelligence. And all this, again, as part of SQL Server. So you can deploy applications into SQL Server. You can deploy web front ends. You can deploy APIs into SQL Server, models, all that. And it will all run natively on the same platform. Let us start with a little primer, just to make sure that at least the rough topics have been named and you get a rough understanding of what they are. Again, we're not going to do deep dives on most of them. Foundations of scale. You may have heard of Hadoop, and if you have not heard of Hadoop, think of Hadoop as a supermarket. Think of a supermarket, you're standing in line at the cash register, there's 4 people in front of you. What's happening? The supermarket may just open a second cash register. Instead of 4 people waiting there, there's now 2 people waiting at each register, obviously speeding up the process. That's kind of what HDFS does. It doesn't do it to make you pay for groceries, but it is delivering files to you, with the idea being you have, instead of one big flat file, you have multiple small flat files that are being spread across multiple nodes, across multiple servers, and therefore multiple servers can do the spread and the scaled out work on exactly that, and that data will then be aggregated, therefore making working with file-based data much faster because it's distributed. And then there's a thing called Spark, which is basically the same thing, but in memory. Technically not 100% accurate, but we leave it at that for today. You've certainly heard of virtualization because we've been doing this for, well 20 years, something like that. The idea of virtualization is, instead of whenever you need a new server, you actually take bare metal and put it into a shelf and put it into a rack. Instead of that, you fire up one physical machine and then fire up multiple virtual machines on that physical machine, which means they just share resources. They share the network, they share kind of the memory, I mean, still isolated processes, but physically speaking, that's what they are sharing, CPU, everything. With the big disadvantage being, they're still completely independent. So let's imagine you have these 3 virtual machines on one physical computer. They're all running SQL Server. They're all kind of doing the same thing still. If Microsoft releases a new update for Windows, if Microsoft releases a new update for SQL Server, if Microsoft or any other vendor releases a new update that needs to be applied, it will need to be applied to all of these virtual servers manually. I mean, you can automate that with PowerShell. You can automate that with update services, so you don't technically have to log into every single one of these servers just to push the update, but you still need to maintain all of them. Then a couple of smart people came along with the idea of containers. And we're like, well, you know what? First of all, that's a waste of space, because why would I need 4 full disk or 3 full disk in our example, all holding the exact same data? Doesn't make much sense. And also applying those updates every single time to all of them, that's a waste of resources, that's a waste of time, that's a waste of money. That's how containers were born. And you may have heard of Docker. Docker is probably the most popular container platform, but there's others out there. The idea with the container is you have a shared image, think of it as an ISO file, that you can either create yourself or download from a couple of registries out there on the internet. And you take that image and you just spin that image up to memory, potentially 3, 4, 5 times. So if I need 3 SQL servers, I would just take the same image and spin it up into memory 3 times. You would still kind of end up with 3 virtual machines, though they're containers, and they come with a couple of limitations. But the smart thing about that is, if I have 3 machines doing the exact same thing, you only maintain them once, you only store them once. And that also means, since most of these containers actually run on Linux, they have a very small footprint, so you can have a lot of these containers doing very specific, very small tasks within your ecosystem. Therefore, instead of having tons of huge machines, you can have maybe even more, but therefore much smaller machines, which makes it much easier to push them around across multiple nodes to load balance them, and therefore get way better performance out of the whole environment. The problem with those containers is they don't communicate very well with each other by default. They're kind of islands, if you want so. And then some smart guys at Google came along with a project called Borg. And the idea of Project Borg, which is now better known as Kubernetes, is let's orchestrate those containers. So all of these nodes that you see here, well, these nodes, this is a VM, or this is a PC, or a server in your rack, or whatever. This is some kind of physical or virtual hardware that this runs on. Kubernetes builds the next meta layer on top of that. So this is basically what you talk to, and Kubernetes comes with its own orchestration master. This orchestration master basically does all the magic. So you just say, dear Kubernetes orchestration master, I need 5 web nodes and 2 data nodes, and I need 3 business logic nodes, and I need another 5 analytics nodes. These nodes would all basically be the same. You just scale them depending on how many of them you need, depending on how much performance. And he will make sure that they run on the right node, that it's all load balanced, that it's all performance-wise optimized, and that you just get great performance and also great orchestration out of that. I will leave it at that for Kubernetes for today. If you want to learn more about Kubernetes, I got one recommendation for you, which is, it is actually a children's book, or it is written as a children's book, but it explains the core concepts of Kubernetes very well. Or the other thing that I could highly recommend to you, talk to this guy, Anthony Nocentino, and he will also be speaking at this conference, I think tomorrow. So make sure to check out his content. And he knows everything about Kubernetes and potentially even a little more than that. So for today, we will just keep in mind, there's a thing called Kubernetes. It is kind of a new meta-level deployment structure. And it is mainly talking Linux in our case, because this will be important when we get to the next picture. Because now we're getting back to the big data cluster. What is the big data cluster? What is a big data cluster? What can it do for me? How is it structured? So that's what we've seen before. This is the cluster orchestration manager. This is just the core Kubernetes component that makes sure that Kubernetes is running. And I've split this whole picture basically into 2 parts. So on the left side here, you got the cluster orchestration manager, that's core Kubernetes. You got the controller. This is coming from the SQL Server big data cluster. And this is basically the only component that we will actively deploy. We deploy the controller, and the controller will make sure it will actually deploy all the rest, all the components that we're actually going to be using. There's also a couple of shared services that I will not get into with the interest of time today. There's a container in there that does nothing else basically but to make sure that the whole environment here can speak Kerberos. There's a container here that is making sure that you have Active Directory integration. There's a container that is providing a portal that allows you to monitor the health state of your big data cluster and so on. Lots of very necessary things, but maybe a little bit much for a first-time introduction. So let's get to the exciting part. The actual big data cluster, even though the other components are part of it, but this is where the magic happens. Your first and main entry point into a big data cluster is your SQL Server master. And this SQL Server master is just a regular SQL Server. It is running on Linux, at least in a default deployment, but that is probably the only difference that it might have from any other SQL Server that you may be running, for those of you that are not even using SQL Server on Linux yet. And this is your main entry point into the big data cluster. And this is basically, with one exception that I'm going to get to in a second, the only connection point that you even need to talk to. What this SQL Server master can do with the use of Polybase, it can bring in data from other sources. And this is the only exception to what you're going to see with what would also work in a standalone environment. So you could now go ahead, install a SQL Server on Windows, SQL Server 2019, just tick the Polybase components in the installer, and you would get what you see now. Polybase has been around since SQL Server 2016. And the idea of Polybase was back then, and it's also the core foundation of Azure SQL Data Warehouse, or now Synapse, bringing in data that sits in flat files, bringing in data that sits in external data sources, basically. And in 2016, 2017, it was rather limited to exactly that, those flat files. And what Microsoft did now, Bob Ward calls that Polybase ++. You can call it Polybase 2.0, Polybase proper, Polybase yay, whatever you want to call it. The idea of this Polybase concept is you create an external table, and that external table is pointing somewhere else. But instead of just having flat files, so instead of just bringing in a couple of CSV, you can now to NoSQL databases, Azure Cosmos DB, MongoDB. You can talk to other scale-out sources, Cloudera, Hortonworks. You can talk to other relational data sources, Teradata, SQL Server, Oracle, and that SQL Server could be an Azure SQL DB, which is, by the way, what we will be doing in our demo rather soon. But it's not just those. There's about 180 data sources that you can currently bring in. You've seen the learning partner CData in between. CData is providing you about 180 ODBC connectors that you can use with Polybase to bring in data from my perspective, pretty much anything. You can bring in data from a SharePoint list. So you could have a SharePoint list that is exposed in SQL Server as a table. So you can do select star from appointment list, but appointment list is sitting in SharePoint. And every single time you run that select will be run against your SharePoint server. Still, from a user perspective, it is exposed as a regular table, basically, with a couple of restrictions that we're going to look into. But keep that in mind. All that data still sits somewhere else, but you can query it like a SQL table. It may remind you of a linked server, which kind of does the same thing. A couple of differences. First difference is, and for me the biggest difference, what the query looks like. A query against a linked server would be select star from linked server name, .database name, .schema name, .table name. What happens if your server name changes? All your queries break. Unless you've set an alias for everything, which most people don't. Whereas with an external table in Polybase, all you do is you change the underlying metadata. Your query will be remaining the same. So your query will still be select star from appointment list, but appointment list may now not sit in SharePoint anymore. It may now sit in your CRM system, or it may now sit in a regular SQL table, or it may now sit in a CSV file. You can change the data source over time without changing the underlying queries, basically. A couple of other differences. This is configured on database level instead of instance level, having the big advantage. If you're running in an availability group, you configure it once and it's in every single database. Or you could also argue, well, some things better happen on the instance level, and there's probably always pros and cons. Linked servers run on ODB, this runs on ODBC, probably more a philosophical discussion than anything else at this point. But just keep in mind, you basically can get any kind of data into SQL Server live without writing any integration services or other ETL packages, and the data will just be there and exposed as if they were a table in SQL Server. And this works in any SQL Server 2019, even if it's just a standalone thing. Anything that's happening from now will only work in big data clusters and therefore only on the Linux-based Kubernetes platform. What you will see happening is we will see so-called pools popping up here on the right side. The first one we have is the compute pool. Within the compute pool, you see another SQL server, and this SQL server is another regular SQL server. You will just not talk to it as if it were a regular SQL server. You would not talk to it directly. The master will talk to it. And it's not just by chance that there's one SQL server in there. There could be more of them. So if I say, well, all these queries against my external data sources, they need to scale better, I could just enhance my compute pool. Instead of having one SQL server in there, I could have 2 instances, or 3, or 4, or 8. Therefore, distributing my workload across multiple SQL servers, therefore having better performance because more nodes are actually doing the work. So you can scale out your queries against external data sources, another huge difference compared to linked servers. The next pool is the data pool. As you can see, this has 2 SQL servers. The reason for that is the data pool does not make any sense with less than 2 instances. Again, 2 full-grown SQL servers in here, and it could be 2, it could be 4, it could be 8. So it doesn't just have to be 2, but in this slide, we'll just leave it at these 2, and also for the demo later on. The idea being, you have a big table. Think of you have a fact table. That fact table has 100 million rows. You take that fact table, you push it to the data pool. What you will end up with is an exact copy from the structure of that table on both SQL servers. But each SQL server will hold roughly 50 million rows, so half of that. With the logic being, querying 50 million rows should be faster than querying 100 million rows, which is, depending on your data structure and data size, not always true. So it's not like the data pool is the solution to everything, but that's kind of its purpose. One issue with the data pool is it does not support transactions. So you this should not be your primary data storage or your only data storage. So think of it as a data cache. And then we have another pool. the storage pool. The storage pool has Spark, and the storage pool has another SQL Server node. Again, it could have multiples of each. And it comes with its own Hadoop file system. And that means it comes with its own data lake. So SQL Server comes with its own file system. I can take data and push it to my SQL Server. I can take data and upload it to my SQL Server using the command line, using a tool called Azure Data Studio. And therefore, making SQL Server also my primary storage for my flat files, which could be CSVs or Parquet. We're going to take a look at that. But if you say, well, I already got some kind of data lake because I'm using AWS S3, I'm using Azure Data Lake Store, you could just bring that in and tier it to your SQL Server. So there is no need to have everything in SQL Server, but there is the option to do so. And last but not least, there is one more pool, which is the application pool. And this is, it does everything and nothing, kind of. So this is where you can run machine learning. This is where you can run AI. This is where you can deploy web applications. This is where you could run integration services packages. So like a whole lot of things, but you need to give it a specific purpose. We're not going to take a deep look into the app pool today. And that would be the exception to the rule that I've mentioned earlier, where you only talk to the SQL Server master, because of course, if you're deploying, for example, a web application for your users would be talking to that application, not to the SQL Server directly. The nice thing, if we go back to the storage pool just real quick, you see the Spark part there? This is one of the amazing parts, and we're going to see that in the demo as well in a sec. You can talk to your SQL Server using the data sitting in your SQL Server, using the Spark node or the SQL node, basically all using the same endpoint, because it will only just connect to the SQL master. So I can talk to in Python, in Spark, in Scala, in T-SQL, all talking to the same endpoint and all using the same data. So thinking of traditional environments where you would have one environment for your data scientists, one for your machine learning experts, one for your T-SQL developers, and so on. And everyone kind of needed their own storage and their own data, even though it was the same data, but they all needed it in kind of different formats because they were talking in different languages to it. That would be a thing of the past, because now you're all talking in the language of your choice using one unified data store to it. So having that said, let's take a look at what this actually looks like. So I'm going to switch to my demo here. So I am in Azure Data Studio. And before I get started with the demo, I want to use 1 to 2 minutes to talk about Azure Data Studio, because it is very important for you to know about this tool. First of all, you can use Azure Data Studio when you're on-prem. Just because it's called Azure Data Studio does not mean it is just for the cloud. I still talk to people regularly that are under the impression that they cannot use it because they're on-prem. This is not true. You can use Azure Data Studio on-prem just as good as you can use it for any cloud workloads. Azure Data Studio is not going to replace Management Studio. It is going to be run side by side, and still it has a couple of advantages and also disadvantages. So it will depend on the use case. But you will see a couple of wizards today that are only in Azure Data Studio, that will not be in Management Studio, that will help you a lot working with big data clusters. Only Azure Data Studio will expose the file system, the HDFS, to you. Management Studio will not. Azure Data Studio will natively run on Linux, on a Mac, or on Windows. Azure Data Studio even has a dark mode, if that gets you sold to the idea. So please do check out Azure Data Studio. It is an addition to the client tools. It is not a replacement for Management Studio. And still, it does a lot of things different and a lot of things better. It also comes with the concept of notebooks that I do not want to waste too much time on explaining, but most of the demos that you're going to be seeing, also the one that you see here, this is based on a notebook, a so-called Jupyter notebook. And the idea of a notebook is it gives you way better exposure on formatting compared to a regular SQL file. It gives you a better way to have code and comments and all that separated. I could also add pictures to this. And another thing is, if I run a command in a notebook like just this one, this result here would actually be stored in the notebook. This may not be super valuable to that specific example, but that means if I save that notebook and give it to you, you would see exactly the result of my query. So it is also super valuable for lots of DBA and other tasks where you just want to not just pass on queries, but also pass on results instead of just running a ton of screenshots and pasting them into Word or an email. So having that said, I'm connected to my big data cluster here. And in my big data cluster, I just created an empty database called DataVirt, like data virtualization. And if I right mouse click that in Azure Data Studio, I have installed an extension because Azure Data Studio is based on the same base as Visual Studio Code. So it comes with extensions. It comes with a wizard that says create external table. And if I run this, it will pop up said wizard. And that wizard gives me the option to bring in external data from SQL Server and Oracle. There's another wizard that we're going to take a look at that brings in data from CSV files. For the about 180 different sources, there is no wizard at this point, so you would have to go to the documentation. But still, once you get the core idea of how it works, and you're going to see a lot of repetition on the general logic on these external tables, I'm pretty sure you can do that on any kind of data source. So we will pick SQL Server as our source because we will just bring in some data from an Azure SQL database. The next thing this wizard does, because this is a brand new database, it is asking me for a master key. The reason for that being we will be storing a username and a password to connect to that Azure SQL database, and SQL Server thinks, well, if we're saving a password, it's probably a great idea to encrypt that. I agree. So this is what this master key does. This step would only come up if you're doing this for the first time. So if there is no master key set, otherwise it would skip it. The next thing, for our external data source, we will need to give it a name. I will just call it AW like AdventureWorks, and I will do the same thing for the credential name. We will need a server name to connect to. We will need a database name. And then to connect to that database, we will need credentials, which in our case are a username and a password. If I had done this before, so if this would not have been an empty database, I would have been able to select existing data sources and existing credentials here. So what this wizard is now doing, it is connecting to that database and it's reading the structure, it's reading the meta structure of that database, giving me an overview of all the tables, of all the columns, of all the views in there. So this is the structure of my database. This is the structure of one of the tables. What you can see is these are all my columns, including all of their data types, including their collations, including the information if they're nullable or not. You cannot change that. This is a direct looking glass into your source data. So the metadata of your external table needs to match the metadata of your underlying table. I could not just say, well, title is now an int, because you would get conversion errors whenever you query. The only thing that you can change is my target schema and my target table name, because my sales LT customer, in my case, would become DBO.customer. I could change the schema if I wanted to. I could change the name of the table, like for example, anything coming from AdventureWorks becoming AW underscore something something, so AW underscore customer. We just leave it at what it is. That's the only thing that you can change. Any kind of conversions you need to do, this would happen in your query. So if you need a lot of conversions, it would probably make sense to probably just have a view on top of your external table. Next step, it's giving me a brief overview of what we're doing. We're creating the master key, we're creating the credential, we're creating the data source, which will be using the credential, and 2 external tables. And I could either just create it or I could generate a script, which is what I'll be doing. So you can see first what is happening here. So we're creating an external data source. This is my server name. This is my credential we're using. And then we're creating an external table here. Let's just use this example. Create external table, customer address. This is the important part. This basically looks like a create table statement, but instead of create table, DBO customer address, we're adding the hint external. So this data is sitting somewhere else. This is default basically again. These are just my columns and data types. But instead of on primary, instead of file group 1, instead of partition scheme, whatever, this is a pointer to a data source. So my data source is AdventureWorks. And this is the database schema and table name, the underlying. This is what would be hard-coded in your linked server queries. This is now dynamic in the metadata. So if any of those changes, You just update the metadata, your query against customer address would remain the same. So if we just run this, if I go to my data virt, it's showing me these two tables here, just with the hint external. And I can now go ahead and say, select top 1 from customer, or select top 10 from customer in a joint customer address. The interesting part being, this looks just like any other regular SQL query. Let's just take the smaller one, put it in here, run it real quick again, and look at the execution plan. This is the difference. All your cost is sitting in an operator called remote query, because pretty much nothing of what happened here, except of displaying the data, happened in SQL Server. Everything happened at a remote source. That also is a thing that you need to keep in mind when debugging your queries. You got a slow query. If it's a remote query, there might be a ton of reasons for that. The reason might be the underlying database or the underlying view is just slow. There might be latency in between. If we had a little more time, I would show you how this compares to a database sitting basically in the same data center, whereas running this against a database sitting on the other side of the world, obviously you get more latency, queries get slower. That is stuff that you need to keep in mind when debugging your queries. And that also means this is a very simple and very easy and also very efficient way that you can use, to bring in external data, but it is not going to replace all your ETL needs. Because for some of the data, you will need history. You would not get that in live from your source system. Also, you would not want to hit your ERP system with every single query every single time, because your analytics queries might be completely different from what you would usually use your ERP system for. So this is great for any kind of real-time query. This is great for any kind of data that is potentially coming maybe from another data warehouse and you're just building a virtual super data warehouse. This might be great for a couple of other use cases, but do not use it just to replace every single integration services bit or any other kind of ETL bit that you may have sitting around somewhere. So let's just clean these two up and take a look at the storage pool. So another thing, and like I said, you only have this in Azure Data Studio. If you connect to a big data cluster, you will see another folder called HDFS, and I've already pre-populated some data in there. So I got a couple of CSVs here, basically a list of airlines, a list of airports, and a list of flights. Flights basically being our fact data. So now there is another wizard. Create external table from CSV files. Let's click that. So what this wizard will do is, it will kind of do the same thing. Hang on. It will create another external table, but this external table will not sit in another SQL database. It will sit on the storage pool in the file system. So we will be querying a CSV file live. First thing this wizard does, it asks me which database should this happen in, what's the name of the table, what's the schema of the table. We'll leave all that at the defaults. First thing it does is it gives you a preview of what's in that file. And if you're slightly aware of the airline system and everything, and you look at that, you will probably say, well, this should probably be something like a car2 or maybe ncar2, but you wouldn't even need that because there's no Unicode characters. Well, what this wizard does, it analyzes the first couple of rows and comes up with a suggestion for data types. And the smallest suggestion it makes for tax is an NVARCHAR 50. This is only 14 rows, so I don't really care about it. If this would be a bigger table, keep in mind that data types do matter, because when querying and using them, they use up your memory, they use up your footprint. So it is very important to take care of that, not in our specific case. So I will just say next. It gives me another overview. I say generate script, just like we did before. I will connect. And it looks very similar again. First of all, it is creating a format for me that I just called CSV, which is not best practice because that's kind of like calling an index. Well, it's still an index and it would still work, but it wouldn't tell you much what it does. So better call it something what's actually behind it. We're creating an external table again, dbo.airlines. These are my two columns. These are my two data types. But this time I'm providing a format. My data source is not AdventureWorks, but the storage pool that you've seen in the previous slide, actually. And we're pointing this to a CSV file directly. You can either point it to a file or you can point it to a directory. If you point it to a directory, the only thing is you have to keep in mind all these files need to be the same. So imagine a folder where your web server spits in log files every single day, every single hour, every single minute. They all have the same format. You do not need an external table for every single file coming in there. You just put it on the directory and you're done. Just keep in mind they all need to share the same format. So let's run this. And again, we can do select star from airlines. Getting a list. This looks like a regular SQL query, as if I was querying a SQL Server table, but I was just querying a flat file. Every single time I hit that, there is no cache or anything involved. It will read that flat file. So obviously, for those 14 rows, that goes relatively fast. Half a second could be a bit faster, but half a second is completely fine. Keep in mind, this might be an issue for bigger files that you need on the fly every single time. If you already know the structure of your file, obviously you do not need to go through the wizard. You can just go ahead, do what I'm doing here, and create another external table called airports, pointing to a different file. Select top 5 from airports. There we go. And then we're going to run that wizard one more time against our flights file, because this is where it's getting interesting. As you can see, well, way more columns, way more rows, hard to tell. It comes up with a couple of suggestions, but what you see, well, small int, tiny int, as pessimistic as it is about strings, just as optimistic it is about numeric data. So what will happen is, there's a couple of tiny ints down there. What this wizard basically does, like most of these wizards, and I just created that, is it will analyze the first couple of rows and then come up with a suggestion. So this top 10 works perfect. If I join these together, this will run in an error. With the error being, well, in row 14,500 in column 27, air system delay, we get a load data conversion or we're getting an overflow. So that means the wizard thought, well, tiny int would be fine for this, but apparently it was not. So somewhere in row 14,500, there is a value in that specific column that is just too high for what the wizard thought. So just like every single time you're working with flat files, let's just drop this and recreate this and rerun the other query. And it will take a little while, but it will come back, and this time without the error. Whenever you're working with flat files, either whoever provided that flat file for you will also need to provide you a schema, or if you do not get that schema provided, there will be some trial and error involved. There is no way for any kind of wizard in a well-performing way to always fully analyze the full scope of all these CSV files you have. So as you can see, this already takes a little bit longer because it's now actually really going through the full flat file, which has a couple of million rows, and then grouping all that together. And this is actually what I wanted to show you. This is taking a while. And the reason this is taking a while is because it is reading that flat file live in full. And it would do so again if I rerun this query. There's two things to keep in mind and how you can work around that. First of all, CSV is not a great format for big amounts of data. It is a great format for data to be written. It's not a great format for data to be stored. So what you should consider is either take the fact data, potentially only the columns that you actually need, and push them to a SQL size table, either in the master or in your data pool. Or the other thing that you could do is convert your file into a Parquet file. Parquet is basically clustered column store for flat files. Let me just do this. I will create another external table, which is a CSV file, and run just a select count star against it. So this took 4 seconds, 6.77 million rows. Now we're doing the same thing again, just running it against a file that has the same content, but that is a Parquet file. Well, instead of 4 seconds, this just took about half a second. So 8 times faster. I've seen up to 100 times faster using Parquet versus CSV. And since SQL Server 2019 supports native Python, that means in SQL Server 2019, you could automatically come up with a process that just takes every single CSV, at least the bigger ones. Doesn't make sense for the small ones because then you actually lose more time on working on the compression. Then you get benefit out of it. But for any kind of fact table, basically, to automatically convert it to Parquet, it will save you storage because the Parquet file is much faster, and it will make your queries go way faster than they would be using that CSV. So you may not even need to push that into a SQL Server, into a SQL Server table. You may still be able to query it file-based, just using a different format. And this is 2 lines of code in Python to basically convert a CSV into a Parquet file. Next step, data pool. So keep in mind, we have a thing called the data pool, and the data pool is just a couple of SQL servers behind our master instance. I'm creating another external table. These are my column types. This is the name. This time it is sitting on the data pool, and I'm using round robin. There's 2 distribution types, round robin and replicate. Round robin would mean I take my 100 million rows and push them half here, half there. It's not exactly half because it does it in increasing chunks. So you'll probably end up with 49 million dot something left and 50 million dot something right. But you get the idea. Replicate would mean that you get the exact same data in both of them. That would make sense if you're actually pushing dimensional data, for example, to your data pool. What is happening here in this case is SQL Server will connect to every single instance of the data pool and check, is there a database in there called DataVirt? Because that's my current database context. If not, it will create that database for me. It will then check or create an external table, or well, actually a local table in each of them, having exactly that structure. And it will then create the external table, which is kind of a union all across all those pools. So that's also why it actually took about 7 seconds, because it had to create 2 databases, 2 tables, and 1 external table to point at it. And I can now go ahead and just say insert into my data pool, so into my external table from that Parquet file that we've had before, and then I can query it again just like any other table. Select count, select top 10. Well, since at this point there's only 10 rows in there, the top 10 is almost obsolete. And the other thing that I can do is I can directly connect to my data pool using a query hint at data source, SQL data pool. What this will do is it will take this query, run it against every single node in my data pool, and bring back the result. And what this does is, as you can see, I get 2 nodes. That's why I'm getting 2 replies. One is holding 10 rows and one is holding 0, because SQL Server decided, well, for 10 rows, it's not even going to bother to split that up in any way. Let's do this. Let's truncate the table and not insert 10 rows, but insert our 6.7 million rows. Again, this is going to take a little bit. And if we run our data source, our query at data source again, this will give us the result showing, well, 6.7 million, that's about 3.6 million each. That's where we're going to end up, half here, half there. And again, if it would be not 2, but 4 nodes, you would end up with roughly 1.8 million each. So let's run this first. 3.384 versus 3.385, which is interesting because that means in this case, the second node even got a little more records than the first one, which shows you how the increasing chunks work. Still, as an actual use case, I would still say select count or select top 10, get exactly that result, and would treat it just like any other SQL table out there. So from a user perspective, completely transparent. I've just spread out the workload. So obviously for a count star or for a top 10, it's not that valuable. But if you would add some kind of predicate, some kind of where statements, all that, this would now run distributed across all my nodes in my data pool. We will not go into detail with that. The only thing I wanted to show you here is If you're using Spark instead of T-SQL, you can do that using the same endpoint. I'm still connected to the very same SQL Server, but instead of use this database, instead of doing select this, I can just say Spark read and read the files directly from my storage pool. Or I could do the very same thing against my SQL Server table or against my AdventureWorks database in here and all that. So let's talk briefly about tools. There's basically 5 tools, or well, let's group them into maybe 4 together, that you will need to work with a big data cluster. The first one is a tool called kubectl. My friend Bug Woody calls it kubectl. This is what's controlling your Kubernetes environment. And I'm pretty sure Anthony will have a couple of things to talk about around kubectl in his session. So this is providing your infrastructure, basically. Next is a tool called AZ Data. AZ Data is the tool you're using to deploy your big data cluster. Third tool is Azure Data Studio, which we've just seen to interact with your cluster. I could use it to upload files there. I could use it to download files, to manipulate files, to run queries in Spark and T-SQL. I could also deploy a big data cluster from Azure Data Studio, but Azure Data Studio would do nothing else but actually run AZ Data in the background for me. And then there's 2 interfaces, the Kibana and the Grafana interface, which we're also going to take a brief look at. The Kibana and the Grafana interface provide you a looking glass into your big data cluster, basically. That means you're getting 2 websites, and we're just going to take a look at one because I just want to get you the general idea. You've seen that big picture with all the components. You got your data pool, you got your storage pool, you got your master, you got all this. There's 20, 30, 40, 50, maybe even 100 different containers, 100 different computers that are holding log files, that are holding CPU and stuff that you potentially need to talk to, they need to connect to. What these 2 interfaces, what these 2 websites do, it just aggregates all the data behind that. So if we take a quick look at that, we can also do this from Azure Data Studio. So Azure Data Studio also gives me a management view into my big data cluster. So I'm just clicking here on my Grafana interface. This is my looking glass into, so I could select, well, what's in my compute pool, what's in my data pool, what's happening in my master. So you get SQL metrics. So what are my wait stats? What are my batch requests per second, transactions per second? But I can also look at host node metrics and look at stuff like, oh, how long has this been running? What's my CPU usage? What's my RAM usage? Go down to every single disk. Look at all the different components in my cluster using one specific, one unique looking glass into the whole thing without the need to connect to all the single components in my cluster. Deployment. Like I said, there's one simple way. If you only care about Polybase, you do not need to worry about Kubernetes or all of that. If you only care about the Polybase part, you go to microsoft.com/SQL, get your SQL Server 2019, download that, install that for either Windows or Linux, whatever your preference is. Just make sure to include Polybase in the installer. Enable Polybase after installing it, so it has to be installed and enabled. Restart your SQL Server. In theory, that means you're done because everything can be controlled through T-SQL. So there is no need to have Azure Data Studio still. If you're new to this, I highly recommend it because Azure Data Studio with that data virtualization extension gives you the exposure to that wizard, and that wizard just helps you a lot understanding the core concepts of Polybase, external tables, and the T-SQL behind it. If you care about the full package, first of all, you need to decide on a Kubernetes environment. You can run Kubernetes in the cloud in Azure on a product called Azure Kubernetes Service. This is what I'm doing here. You can run Kubernetes on a local Ubuntu machine using a tool called kubeadm. You can run Kubernetes using kubeadm on multiple Ubuntu machines. You can run Kubernetes on VMware. You can run Kubernetes on a ton of platforms. Not all of them are supported. In theory, you could even run Kubernetes on a Raspberry Pi, but the Raspberry Pi will probably not get you the performance you want for your big data cluster. Install your Azure Data Studio and the data virtualization extension. And by the way, on the environment, if you got some Azure credits, I would highly recommend you to use Azure Kubernetes Service to start with, just for the reason Azure Kubernetes Service setup, super easy. It does everything for you. And once you're done, you just delete the cluster again. And this even works with one of the free trial subscriptions. You need some prerequisites. We're going to take a look at those in a second. And then you just deploy using AZ Data, potentially through Azure Data Studio. You can either do that from the command line manually, or you do it through ADS. And we're going to take a look at that as well. For the prerequisites, if you're not aware of a tool called Chocolate or Choco, you should be. Choco is a package manager. And the nice thing about that, the very first line of this slide here, it basically goes ahead and installs Choco for you. And after that, you can just say, Choco install something, something. So if you go to a completely new Windows machine and just take this slide and copy and paste it into a PowerShell, this will install all the prerequisites you need. So it will install the first four. I color-coded them orange. These are not official prerequisites by Microsoft. You will still need them, because if you debug a big data cluster, the debugging file will be a tarbor file, so tar.gz. Windows doesn't do well with them. 7-zip does. Once you've opened that file, there might be a log file in there that's potentially gigabytes in size. Notepad doesn't do well with that. Notepad++ does. Curl or curl, command line tool to interact with web services. This helps you to push data into your SQL Server. This helps you to push flat files into your HDFS. SQL Server command line utilities. This you can use to restore data like backup files in your big data clusters. It just makes your life easier. You technically don't need them. All the others you actually do need, so that it installs Azure Data Studio, it installs Python, it installs Kubernetes, and it installs AZ Data for you. I also got a link for you here to that GitHub repository before we take a look at how the deployment would look like from Azure Data Studio. The cool thing about that script here on GitHub is what this thing does is it will connect to your big data clusters. You provided the name of your cluster and the IP address and your password and stuff like this. And it will assume that you're just using the default ports. And then it will restore a sample sales database, and it will push some CSVs there, and it will create a couple of directories in your HDFS. The data it is using is not super meaningful because it is sample data. But the cool thing is this script, and it only has about 50 lines of code. This will upload a sales database from Microsoft to the big data cluster. If you don't want the Microsoft sales database but your own, just replace Microsoft sales database.bug with my production database.bug. This script will basically teach you in a very easy way on how to interact with your big data cluster, which in case you've never worked with Linux before, in case you've never worked with Kubernetes before, in case you've never worked with a Knox endpoint for the HDFS before, this will teach you how to interact with them and how to actually automatically push data in there. Because even if you can do that manually once, you don't want to keep uploading and pushing data manually to your big data cluster through Azure Data Studio. So let's switch back to the demo one more time. Up here, very well hidden in Azure Data Studio, next to the connections, there are 3 dots. And I have no idea why they're hidden so well. They have only one menu item, and that's called New Deployment. If you hit that, it gets you to a screen that allows you to install SQL Server on Windows, which will just take you to the download page, SQL Server on containers, or also a SQL Server big data cluster. First thing this will do is it will check, are all your prerequisites that we've mentioned before installed? It will also ask you, what is the Kubernetes platform that you're looking for? And this right now supports AKS, either you're an existing one or an existing kubeadm cluster. In theory, it's also asking for the version, but since big data clusters is only SQL Server 2019, well, this obviously only gives you that single option. Let's just pick this one. And then this wizard will basically walk me through all the details for my big data cluster that I need. It's coming up with a couple of suggestions. So is this a dev test or a high availability environment? We just go with dev test. Next. It's going to ask me for an Azure subscription ID. We just put anything in here because we're not going to deploy that. It's asking me for a password. And then it does stuff like how much data do you actually want to store in there? The default is just 15 gigs. And obviously you can change that. You can change that for the different pools as well. How many instances do you want to have in your data pool, in your storage pool and all that? And once you're done, gives you an overview. And then it would script it again to one of these notebooks that we've seen before. And if I would go ahead and run this notebook as it is, this would do the full deployment of a big data cluster for me. So at some point this is done. And once it's done, it will come back with the information. This is the IP address of your big data cluster. This is the port of your big data cluster. And then you can connect to it using Azure Data Studio. And by the way, Azure Data Studio is also your first looking glass in the overall state of your big data cluster. So my big data cluster here, it's ready. It's healthy. Every single component is healthy. It would show me if one is not. It would show me the reason for. And it would also come with something called troubleshoot. This is, again, just a bunch of notebooks walking me through what could be wrong with my big data cluster. So do this step, do this step. Can you actually log into your cluster? Run this notebook. If you can log in and it's healthy, this and this is still, this will walk you basically through all these single options up to the point where you will either get the answer to why your cluster is not doing what it should, or at least give you enough information, enough feedback so that you can provide that to an engineer to work on that problem with you. And with that, we get to the end of the presentation and I would be ready to take your questions. Amit, I don't know if we can enable the chat for feedback again. And otherwise, I will take a look at the Q&A board right now to see if there's any questions in there. Okay, so there's a couple of questions. I just need to see. Whoa, okay. Do we have the capability to bulk copy from the external table using Polybase in case we need to have a copy in SQL Server? Yes, the external table, think of that, it is just a regular table. So you could even do a select star into something from that Polybase table. That would work. The only thing that would usually not work is the other way around. So usually Polybase is read-only. There's, again, a couple of exceptions, but if that data, in my case, coming from that Azure SQL DB, I could not write into that. So copying data from a Polybase table into SQL Server, no problem. Just treat it like any other data source. And you can either use T-SQL for that, or you can write a stored proc, which technically is also T-SQL, or you can use integration services or any other kind of source. Can we expect an equivalent performance compared with data being in the database versus external tables from Teradata? If it is very poor, it may not help the recommendation. Very hard to tell. It will depend on too many things. I highly recommend to just try it. So it depends on the queries. It depends on the latency. It depends on how far is your Teradata apart from your SQL Server database. So is there network latency? So I've seen cases where the performance was very, very equal. Obviously not better because the underlying limitation is still your Teradata database. So your Polybase query will never be better or better performing than your direct query. But I've seen many cases where the overhead was so slim that you basically didn't need it, that you basically didn't see it. But I've also seen cases where the overhead was so horrible that it became almost unusable. SQL Server made the comment with data virtualization, integration services, and ADF are redundant. As I've mentioned, I disagree because of so many things. Think of that. You have something like a slowly changing dimension. You could not get that through data virtualization because data virtualization would just get you the raw data. Can the compute pool have multiple SQL Server instances? Yes. If we say Polybase, a little bit similar to linked servers, isn't synonyms an alternative? What is the difference between synonyms and Polybase? So it's not the same thing, and technically they're completely different from how they do it. Generally speaking, I would sum it up with Polybase is mostly easier to use and better performing. But again, this will come down to the specific use case. Can we import data from Postgres? Yes, you can also use Postgres as a source. Postgres is just not shown in the wizard, so you would have to come up with the T-SQL itself. Is it advisable to change linked servers to Polybase? Generally speaking, I would lean with yes, but again, it will depend on your use case. Oh, and by the way, I will keep going with the questions, but all my contact details are up there. So please feel free to connect with me on LinkedIn, to connect with me on Twitter. Also, if there's any follow-up questions, always happy to keep the conversation going. Without an Azure subscription, can I have Big Data Cluster on premises? Great question, and the answer is yes. So Big Data Cluster is part of SQL Server 2019, which is the on-prem product. So Big Data Clusters can run on premises, and they are designed to run on premises. So even if you run them in Azure, you would still be managing them. So it would be infrastructure as a service. It would not be a platform as a service approach. So you can deploy them anywhere, just like you can install SQL Server anywhere, but it is designed as an on-prem product or as a self-managed product. And that means if you don't have an Azure subscription, just install a local Ubuntu machine and you're done. What are the hardware and software requirements for an on-premise big data cluster? So you will need, every single node will need to have at least 32 gigs of RAM and about 100 gigs of disk space, plus obviously the disk space that you will need in your system for your data to be actually stored. And it is recommended that all of these nodes are the same. So I would, if you just want to take a quick look at it, just fire up one Ubuntu machine, 32 gigs of RAM, 100 gigs of disk plus a little disk for the data, and you're good. If you actually want to run a full cluster environment, you may need a couple of these machines, but these can be virtual. So when an external table is read from a source, if other users are reading, modifying the same table, do you encounter blocking? It will depend on your query workload. Can we use DML operation on an external table when the source is CSV? Not at this point. So what is the difference between SQL Server 2019 Polybase and BDC? BDC is the full picture. 2019 Polybase is one feature, and that feature is in big data clusters and a standalone SQL Server. So Polybase is the thing that basically reads from other sources like SQL Server, Oracle, Teradata. Whereas BDC, that's the whole installation, including the storage pool, including the data lake, including the data pool, including the application pool. PowerPoint for download, yes, that should already be at the event website, or if not, it will be available to you shortly. So Raul has the question for an external table. Can you allow subdirectories, and can you give them zipped CSV files? Answer to both at this point is no. If you provide the directory, it will not recurse down, and it would only read native CSV files. But still, I would highly recommend anyway, not converting them or not zipping them up, but converting them to Parquet. Because if you have a Parquet file, it will perform so much better than a zipped CSV or a plain CSV. So Dirk has a question regarding the data pool. If I have a table with 400 million rows and it sits on the data pool spread across 4 nodes, so 100 million rows each, where will the data be processed for like a hash join when the table is joined with itself? In that case, that would have to go back to the compute pool, because the single, if you're actually joining it against itself, the data pool would not have that information, because the single data pool nodes are independent of each other, so they don't talk to each other directly, to the best of my knowledge. Then again, I've never tried joining a fact table against itself, so maybe we would need to look into that. So feel free to ping me afterwards, and I'm happy to run a test query with you. What could be done if the data storage is huge using external source? I'm not sure I get that question, so you may want to come back to me a little more specific on that. Are external tables cached in SQL Server memories before they are delivered to the client application? They are not cached. I mean, they run through the master instance, so they run through memory, but they're not cached in there. You can write stored procedures using these external tables. You cannot write triggers. So For a trigger, you would need SQL Server. So also an external table can have a statistic. It cannot have an index, because for an index or trigger, SQL Server would need to own the data. Does Azure Data Studio support older on-prem SQL servers like 2016 or older? Yes, you can connect to SQL Server 2000 using Azure Data Studio and it would still work. Obviously with all the limitations. Some tools we can associate for data visualization tools in big data. It depends. Many users, many people are just using something like R or Python and the integrated visualizations. You can use something like Power BI, and then there's a ton of other tools out there. It would really depend on what your use case is, what you're trying to do, and also who you're going to deliver this to. So is this going to be a nice dashboard, or is it more a work in progress analytics kind of thing? Will it be possible to use a result set caching? Not at this point, and to the best of my knowledge, no. But then again, don't quote me on it in a couple of years, because at some point this may be coming or not. At this point, you would be responsible for the caching yourself by potentially caching through the data pool, for example. And any hand, if Synapse or big data clusters will converge somehow in the future. I don't think so, because while there is overlap, they do things different. And I think in the end, they address different use cases, a part of the fact that architecturally Synapse is a pure cloud product and BDC is a product designed for on-prem. Does SQL Server big data clusters use PDW, MPP concepts internally? No, big data cluster is not an MPP system. Regarding the source code that I've used, I can share the one I have, but I would highly recommend you use the one that actually sits on the Microsoft GitHub, because that would also work with the Microsoft sample data. Still, if you need any of that, feel free to ping me afterwards. Then Satya, that's more for you, feedback. If you could enable the chat. Is Azure Synapse a big data cluster internally or flavor it? No, it's two completely different teams, two completely different products. So Vaibhav, your question on compatibility level, I'm not sure I fully understand it. Maybe get back to me on that, if that even was for me. And so big data clusters, is SQL 2019 only for big data cluster and Polybase, or for regular? So there is a big SQL Server 2019. They will just run on Windows using availability groups and run it on Windows just like you used to. And there's big data clusters, and they're both SQL Server 2019, just using slightly different install base architecture. Inside, it's the same SQL Server code base, because SQL on Linux is the same as SQL on Windows. You may want to have a look at Bob Ward's book on that. But regular clusters on Windows for SQL Server still exist like they always used to. And then we have one more question. Is data pool similar to partition table? It's not, because in a partition table, you would say, well, anything that sits on Monday goes to that partition, Tuesday, that partition, Wednesday, that partition, whereas the data pool is not partitioned by any logic, but at this point, really just by doing round robin. So one is just sharing the data kind of umbrella style, whereas the other knows exactly which data sits where. Then again, the partition table would sit on the same server, therefore using the same resource constraints, whereas the distributed table in the data pool sits across multiple machines. And I think, or at least I hope, I've answered all the questions. If I missed any, again, please feel free to ping me on LinkedIn, ping me on Twitter, or use the groups on LinkedIn that Amit pointed out. I'm more than happy to take a look there as well and answer any more questions that you may have.
Right. Thank you so much, Ben. This was such a calm and cool presentation, and the demos, loved it, totally loved it. And I was like online hooked up to everything that you were speaking about. Thank you so much, Ben.
Thank you for having me. Thank you for organizing this event. I think it's great what you're doing here for the community. And I think the amount of attendees, I was not able to watch, well, I don't know how many we've had here. You probably have that number, but from the numbers that you've mentioned earlier, it is impressive what you've pulled off in that short time. So thank you very much. And it was an honor to be part of this. Thank you.
Absolutely. And I have now enabled the chat window. The room is open. So people just go ahead and put a thank you note for Ben. He would love to read a few comments there. And please, all of you, please follow the code of conduct. Okay, if anything is rude, I am here, not my friends. Okay, wonderful, thanks. Okay, so if the questions around slides and scripts, everything will be shared to all of you friends. So do not worry about that. About recording, I'm still unsure because we are using the Zoom platform with so many attendees. As I said in the morning, cloud recording and on-prem recording is going on. So we'll have to see at the end of the day how it all shapes up, but no guarantees. So I will request you to please attend sessions live. Ask your managers, hey, can you just give me off for today and tomorrow? I have a lot to learn from international experts. That should be your justification.
And also, thank you all so much for the kind feedback. Very nice to see. So thank you again for having me. And I think the next speaker is also a German speaker. It's Uwe Ricken, if I'm not mistaken.
Yes, absolutely. So, right. So thank you, Ben, and have a good day, whatever is remaining of, I think in Germany, you just started the day, right?
Exactly. It's 9:30 now. So my day is just getting started. So
it's just getting started. Okay. Thank you. Thank you, Ben.
Thank you so much again, and speak to you soon. Thank you. Bye-bye.